Alright, so you are welcome to this episode. Okay, we have already dealt with what fractions are, trying to understand what fractions are. We have talked about doing some operations, addition and division operations on fractions. We also deal with some strategies to reduce bigger fractions into their simplest or their lowest terms. And today we want to do the last bit of operations on fractions, which is adding and subtracting fractions. And we're going to go two ways because addition and then subtraction are on the same level. Whatever principle that we are applying to subtraction is the same principle that applies to addition, right? So the most important, we're going to look at two things: how to add fractions which has same denominators, right? So same denominators. If two fractions have the same denominator and you want to add or subtract, what do you do to them, right? Yes, same denominator. And then we're also going to look at fractions that have different denominators. What do you do to fractions that have different denominators? How do you also add or subtract them? It's a very simple concept that we need to take notice of. Okay, so fractions that have the same denominator. Okay, so when adding fractions that have the same denominator, just add or subtract the numerators. In other words, if I have 7 over 9 minus 2 over 9, the first thing you look out for are these fractions having the same denominator. If the answer is yes, all you have to do is to subtract their numerators. So here you're going to have 7 minus 2 all over 9, right? This is the repeating denominator, and that is 7 minus 2 is 5 over 9. Okay, let's have 8 over 15 plus 2 over 15. What is the first thing? Check if these fractions have the same denominator. Maybe a minute to check. Cool. Yes, so they have the same denominator, which is 15. So what do I have to do? Add their numerators. So 8 plus 2 all over 15. That's going to give you 10 over 15. Now we know how to reduce fractions, so let's simplify this fraction. So this is 10 over 15. This can be written into their prime numbers. Okay, building blocks as 2 times 5. This can be as 3 times 5, and then we know that 5 and 5 will cancel out, so that our final answer should be 2 over 3. Let me give you some more examples. Give this one a shot. Okay, I'll give you some minutes to check it out. So 4 over 7 minus 1 over 7, 1 over 5 plus 1 over 6 plus 1 over 6, 5 over 12. Okay, I'm giving you a minute. Okay, great. So hopefully if we're able to do this, you will get 3 over 7. If you're able to do that, you should get 4 over 5. Here you should get 2 over 6, which will be 1 over 3. Here you should get 10 over 12, which will end up as 5 over 6. Great. So if we're able to do that, congratulations. Yes, congratulations. Okay, great. So that is how you add or subtract fractions which have like denominators. How about when fractions have unlike denominators? Fractions with unlike denominators. So unlike denominators. So let's say I have 2 over 3 plus 3 over 4. Now if we check the denominators here, this is 3 and this is 4. They are not. 3 and 4 are not the same. Okay, in that case, what do you do? Add another level to this principle. So what do we do? I'm sure we were all very comfortable with adding fractions which have the same denominators because we just add or subtract the numerators. So how about changing the fractions to be of the same numerator? So let's look at it. For instance, I have 1 over 2 plus 3 over 7. Now the denominators here are not the same. So what do? I want to make the denominators the same. Okay? And the way you make the denominators the same is to pick the fraction and multiply by the denominator of the other fraction. So I pick the fraction here, 3 over 7. What's the denominator of the other fraction, which is 2? So I multiply that. So here 1 times 7 is 7, 2 times 7 is 14. So my denominator is now 14, and you would see that 7 on 14 is the same as half. 7 is half of 14, so 1/2, right? So the same thing comes here. 2 times 3 is 6, 7 times 2 is 14. So now I've been able to change this fraction to 7 over 14 and then 6 over 14. Remember, 6 over 14 is the same as 3 over 7. So now that these fractions are of the same denominator, 14 and 14, I can simply add their numerators, which is 7 plus 6 over 14, and that is going to give you 13 over 14. Let's do 2 more examples. I have 5 over 6 minus 1 over 5. Are the denominators the same? No, they are not. So what you have to do is to change the denominators to be the same. And we said that the easiest way to do that is to pick this one and multiply it. Pick that one and multiply that. Then you're going to do the same thing. You reciprocate that. This, you multiply that. This, you multiply that. So what you're going to have to do, pick 5 here, multiply by 5, which is the denominator. Pick 6 here, multiply by 5, minus, pick 1 here, multiply by 6. Pick 5 here, multiply by 6. So you realize that 5 times 5 is 25, 5 times 6 is 30. Okay, 1 times 6 is 6, 5 times 6 is 30. So now our denominators are the same, so we can subtract, which is 2 minus 6 all over 30, and that is going to give you 19 over 30. Let's do a couple more examples. So I'm going to do 3 plus 7 over 8. Then I'm going to do 5 over 7 minus 1 over 9. Then I'm going to do 3 over 14 plus 1 over 2. Then the last one, I'm going to do 3 over 4. 3 over 4 plus 11 on 18. So I'm going to give you a minute to do that. Hopefully you were able to do it. Just pause the video and check it out. Hopefully if you were able to do that, you will get 8. 1 times 8 is 8 over 24 plus 21 over 24, and this should give you 29 over 24. This should give you 45 over 63, and then minus 7 over 63. Yes, and this should give you 38 over 63. Here this should give you 6 over 28 plus 14 over 28, and this should give you 20 over 28. If you simplify 2, you should get 5 over 7. And the last one, if we did this right, you should get 54 over 72, and then plus 44 over 72. Okay, and this should give you 98 over 72. And then if you did this right, you should get 49 over 36. So this is a very simple approach. And I guess you understand it. So this is the simplest approach to solving fractions that are of different denominators. The other approach is to use the lowest common denominator. And I think that between that approach and this approach, this is pretty easier to do. Okay? This is pretty easier to do.